Sometimes you hear people talking about science and technology as if they're part and parcel of the same thing, and sometimes science is a separate enough issue from technology because science is often interested in the how and the why, and technology is kind of a what can we do with it. It's a very practical kind of thing. So even when we talk here about materials, well, materials is the term that we use to talk about the stuff that we use to make our stuff. So let's start from the science, because that's what we're a bit more familiar with. You would have learned at some point, probably at several points, that matter is anything that has mass and takes up space. And that's true, but it's also the scientific definition. So when we talk about materials, the stuff that we use to make our stuff, well, what kinds of things are we going to be talking about? Most often we're going to be talking about solids. So it's a real focus on that. And if you think about things that you've learned in science before, you really haven't spent that much time on solids. And honestly, in a typical chemistry course, you're not really going to deal a whole lot with solids. And we'll talk about why that is a little bit later. And we also want to talk about fluids. Now, when we hear the word fluid, we typically think of gases and liquids, because those are the things that are going to flow in response to a force. You're going to push on it and it's going to move. Now, yes, it's true liquids and gases are both fluids, and that kind of takes up your solid, liquid, and gas. But in terms of materials, fluids are going to be liquids, and even then, they're going to have some special properties. So we want to talk about solids. When we start looking at solids and we start breaking them down into categories, we're going to come across some solids that are crystalline. And crystalline solids have a very regular, very defined kind of pattern in the particles that make them up. And those particles could be the same kind of particle, as in the case of, say, an element, or they could also be molecules, or they could be different particles in some kind of mixture, but they're going to have a regular pattern. And then you have what's called amorphous. And amorphous, as you can see, does not have any kind of regular pattern. There might be a few sections where the pattern is fairly regular, but generally speaking, there's no real pattern in how those particles are arranged. Okay, now if we take those and we look at solids from a slightly different thing, we start to categorize them a little bit more, we're going to have metals as one group of solids, and if you think about the periodic table, there's lots of metals there. We can have ceramics or glass. We're going to have to break that down a little bit more. Now, we're not going to start breaking ceramics or breaking glass. Actually, we might, but that's not what we mean. Polymers, which we're not really going to focus on too much, but it will depend on when, I suppose, if we have the time. And then composites. Okay, so crystalline solids. We said you could have solids that are crystalline, you could have solids that are amorphous, and then we've had these different kinds of solids. Crystalline solids, as I mentioned, have an orderly arrangement, and metals have an orderly arrangement. So one thing that's really, really important to think about right now is that metals are crystals. And we generally don't think of that, because normally when we think about crystals, we're thinking about salt crystals, sugar crystals, or we're thinking about things that are definitely not a metal. But metals are crystals, and they have crystal shape. And we're going to, in class, spend some time looking at some of the crystal formations and crystal structure of metals. We're not going to be able to drill too deep into that simply because we don't have time and equipment, but they are. Ceramics. Now remember, I had glass and ceramics together, but ceramics are crystalline solids. And when we talk about ceramics, what do we actually mean? Well, the easiest definition for ceramics is that they are ionic compounds, particularly certain kinds, but as sort of your quick little, how do I remember what a ceramic is? An ionic compound. Oxides particularly, if you start thinking about things that would actually be called a ceramic, there are a lot of oxides and some carbonates and things like that, but ionic compounds. Okay, and that means that the other ones are amorphous solids, particularly ones like glass. Remember, ceramics and glass were together, so they have properties in common, but one is crystalline and one is amorphous. And also polymers. Now again, each one of these might have small sections that are going to be a little bit crystalline, but for the most part, those things are going to be polymers. Now I didn't mention composites because they are a combination of several things, and we'll get a chance to talk about those a little bit later. Not going to spend too much time on this. We might talk about it a bit more in class, but what this is a timeline of materials. And as we go through, the more space it takes up top to bottom, the more important it was. So we had a time where metals were really, really important, and they pushed everything else out of the way. But right now, you'll notice that we're in a time where composites and polymers and ceramics and glass and metals are getting pretty close to even in terms of how important they are. We'll pay a little bit more attention to that another time. Okay, quick little summary of these things, and it's not so much how we can tell them apart, because we're still going to be talking about at the smallest level, which we can't really see. But metals, obviously the metallic elements, although we can mix them together and make alloys. Ceramics, as I mentioned, were ionic compounds, so metals and nonmetals. Glasses are kind of metalloids. Now metalloids are things like silicon and germanium. So if you have those within a compound, those will often be good at making glass. Not all the time, I guess, but at least part of the time. And then polymers are typically carbon-based compounds. So your non-metal compounds where carbon plays a really large backbone role. You can have them to be elements or mixtures of elements. So I mentioned alloys with the metals, compounds or mixtures of compounds, and then with polymers it's typically compounds. You can have mixtures of compounds in there as well, but we're not going to worry too much about that, as I mentioned. And as I already mentioned, we've got our crystalline and our amorphous type ones, and then the last one is about the bonding. Now we've probably not talked that much about metallic bonding, and we need to be careful with that term because it kind of suggests that metals form bonds with other metals, but they're not really the same thing as chemical bonds. But we'll spend some time talking about what a metallic bond is in class if we haven't already. And then of course you've got ionic bonding and covalent bonding, and that's the network covalent. We won't talk too much about that right now. And then finally, covalent bonding with some intermolecular forces of attraction. And if IMFA is a new term to you, we'll get there. But what it means is that when you get a lot of these things together, they start interacting with each other, not as a chemical bond or forming new chemical compounds, but just sort of almost a static cling kind of thing. But again, we don't want to talk about static cling, but that's kind of a way we can think about it. Now, let's just take a minute and talk about crystals, because when we think about crystals, we tend to have a particular idea in our head. When you start forming crystals, you start out with probably several different spots where those crystals are going to start to form, and each one is going to start to grow a little bit larger. And you can see that as they grow a little bit larger, each one of those clusters takes, generally speaking, a regular pattern. But as they get bigger and bigger and start bumping into each other, now you have regions where it's a really regular pattern, and where then you have this other regular pattern that's kind of bumping up against it. Those boundaries become important. They may introduce different properties that we want. They may introduce properties that we don't want. So in terms of materials and material science, understanding how those crystals form and what happens when they start bumping up against each other becomes really, really important. By the way, those things are called grains, and the boundaries are called grain boundaries. And if you talk to certain people who are into metallurgy, they'll talk about grains and things like that. We're certainly not going to write all this down, but what I want you to focus on is just quickly looking through those properties, because some of them are familiar to you. But I also kind of want to look at the ones down here that are called mechanical properties, because mechanical properties are those ones of material science. How can I use this thing? What are some of its properties that make it useful? And there's a couple of others, and obviously things like color can be important as well. But a lot of those, how useful and where can I put this thing into as a practical thing, I need to know about how, is it strong? Is it going to be durable? Is it so on? Okay. Once we get to class, what we're going to do is do a bunch of things, a bunch of little station labs where we hopefully get an idea of more about what materials are and how we can tell them apart, but also some other properties, and we're going to try and dig down a little bit into things like crystals and crystal structures and those boundaries and what that means for us. Anyhow, we'll try it and see you in class.